All right, so this is Na2O equivalence. I'll talk a little bit about why we use that in the pulping process and in preparation for our white liquor. So let's review a little bit some of the terms that we use in alkaline pulping. So your active alkali is all your active components that contribute hydroxyl ion, so NaOH plus Na2S for your caustic plus your sodium sulfide. Your effective alkali is your NaOH plus half of the Na2S contribution. Sulfidity is a ratio of your Na2S to your active alkali. And then your total alkalinity or alkali includes all of the components that contribute, including the inactive components. All are expressed in terms of grams per liter of Na2O. And so let's talk a little bit about why is it that we do that. So if you think about how we can describe the reactivity of our active components in the same frame of reference, we want to describe first what it is that, how do we describe the quality of our liquor. So we use several terms: effective alkali, percent sulfidity, and both these are in terms of grams per liter, or a percentage of the composition of the active chemicals, NaOH and Na2S. And so since each of these chemicals has a different degree of reactivity in our process, it's important to be able to have some sort of basis that we can compare to. So using a common basis allows to relate the effective contribution that each of these components has on our Kraft cook. It also establishes the relationship between these active chemicals. And so if we go and review, so again, our active alkali is the sum of the active ingredients in the pulping process. Our effective alkali is the sum of the sodium chemicals that will produce hydroxide during Kraft pulping. In this case, NaOH is completely ionized for every 2 sodium atoms of Na2S. There will be 1 hydroxyl produced. Okay, so that's where the NaOH plus 1 Na2S comes in. Your sulfidity is the ratio of Na2S to the active alkali, and it's expressed as a percentage. Using a Knowles white liquor is typically 25 to 50% sulfidity, depending on the wood species pulped prior to dilution and makeup. The sulfidity, if you recall from your classes, increases the rate of dilution, and it also appears to protect the cellulose against degradation. So a number of reasons we use that. Kraft is the German word for strong, and it was an improvement on the soda process. Many of you will be using the soda process, which is only alkali or sodium hydroxide based. So let's look at how do we compare sodium hydroxide first to Na2O. So if you dissolve Na2O in water, it will dissociate and form 2 sodium hydroxide. So stoichiometrically, we have 1 mole of Na2O having 2 moles of sodium hydroxide, or 1 mole of NaOH is equivalent to half a mole of Na2O. So that we can use that ratio of 62 grams of Na2O molecular weight is equivalent to 80 grams of NaOH, and that's how we can convert our as Na2O calculations to what we have to weigh out in our laboratory. Same goes for Na2S. The only difference is this is actually a theoretical reaction that has never been proven in the lab. For our purposes, it's irrelevant. It's back to establishing the basis of relating our active components. So in this case, Na2S plus H2S forms 1 mole of Na2S plus water. So we go 1 mole of Na2O to 1 mole of Na2S. Ratio of the molecular weights, 60 grams of Na2O is equivalent to 78.1 grams of Na2S. And we can use that when we calculate our actual Na2S that we required in our wet liquor preparation. That's it.